Good morning, everyone. Let's go ahead and get started. My name is Eric Marski, and I'm with ESTeem Wireless. And what we're going to cover today in today's NetLab is kind of a unique one. We're actually going to take a look at some of the tools that we have put together software-wise and what's available on everybody's hardware, really, everybody's computer, that we can use to help troubleshoot the ESTeem wireless systems. What we wanted to do was kind of highlight some of the key features that we have put together that really will help you put together this good, working, reliable wireless network. But before we get too far into it, just to give you an idea of who we are, those that are kind of new to ESTeem, we've actually been around since 1982. We're a publicly held company. We've been in business for over 38 years. We actually are the designer and manufacturer of about 10 different radios, covering different frequency bands, both in the licensed and unlicensed bands. As you can see here on the screen, we cover the 150 megahertz, 220, 450, and 4.9 gigahertz in the licensed bands, 900, 2.4, and 5.8 gigahertz in the unlicensed bands. The big thing is that we are the owners of our own intellectual property. We own all the firmware, software, everything that we do it all in-house. This is not something that we respin somebody else's radio and resell it. This is all done in-house. So the big key to this is we own the life cycle of the radios. That is one of the very difficult part about putting in any kind of instrumentation or automation equipment now is you're always concerned about what is going to be the future of that hardware. And what we've worked very hard on is making sure that all of our radios we do everything we can to make sure they're downward compatible to the previous versions. And everything's designed here in the US. Just as far as a few industries that we cover, what you're going to find here is things kind of fall into three major categories: something that's moving, something that's a long distance away, or something that's just inaccessible or too expensive to run any other way but wireless. So those fall into some major categories. Water wastewater is a good example of that. That kind of fits almost all three categories, really. Oil and gas, mining, material handling, stackers, reclaimers, things like this. Power and energy, wind, solar, everything from power distribution, agricultural, infrastructure and factory floor, even all the way down to automatically guided vehicles, AGVs. One of the few projects that we've done here recently has been in the AGV world, to where we're using actually our Horizon 900, which is kind of a unique application for it, it allows us really to be able to provide the features in a wireless network that weren't normally available, only available really in the Wi-Fi bands, in the 2.4 or the 5.8. We're able to bring that type of speed and that type of meshing, and being able to do the Wi-Fi type of handoff, even at the 900 megahertz. So there's some very unique applications that we've gotten into. Now, what we've covered really this far on the different NetLabs that we have put together, what we've really concentrated, especially on the techie side, is what I usually end up getting into, is how do we make this a successful radio application? Most people have a good working understanding of what the radios do, but most people don't really understand the finer points about how to get this thing to work. So we've covered in previous NetLabs how to do the RF design, how to do a site survey, even covered somewhat how to do the commissioning. But the steps that we've done inside of those, and inside of the site survey, and the exact same steps that we did during the site commissioning, believe it or not, we use the same exact 5 steps to do the testing when we're doing troubleshooting. So when we look at troubleshooting, really, if we want to break this down, now of course troubleshooting is going to break into 1,000 little small potential things. But we want to look at broad categories. How do we tell generally where a problem lies within the wireless system? Well, what we can do is we can actually break this down into 5 simple steps. Okay. The first thing that we will do is we just want to verify, can we talk to the device that has a problem? Because what's going to really show up on normal communication system is you've lost communication to a remote PLC or remote control device. Somewhere in the network, you've lost communication or lost a response from that remote. It doesn't necessarily going to point to what is the problem. Is it radio? Is it power? Is it anything like this? This really will define us and allow us to pinpoint exactly where in the network the problem is. Because if we can pass these 5 troubleshooting steps, the wireless network is actually working just fine. So we need to be able to go through these, and they'll logically make sense as we go through them. So the first thing we do is we take a look at are we able to talk to it? And we go from a very simple thing. How is it programmed? Is it still programmed correctly? Then we check the antenna and the cable. Once that's done, and that then tells us actually a lot of information, we then look at the received signal strength and where do we find that? And then finally take a look at, is the network actually sending data? If we actually are sending data across the network and we've got no problems communicating, the problem is outside of the radios. So these are some very simple things to work on, but let's take a look at what tools we've put together to allow these particular things to function. Okay? The first step really is Ethernet communication. In other words, can we talk to the radio? Seems pretty simple. So what are we actually testing? We're testing to say, does our computer and the radio be able to work? So in other words, is the Ethernet port on the radio still functioning? It's very possible that that has been damaged or something is, gotten in there. Of course, we can be dealing with cables and all the rest too, but are we able to talk to it within the network? Now, there are some very simple ways to do this, okay? The first thing is that you can go in and you can simply try to ping the IP address of the radio. Now, a ping test we use a lot, especially on Ethernet. It's a very, very powerful tool because all computer systems actually have this that are running TCP/IP, have this as a base function. Doesn't matter whether it's Windows, Linux, it doesn't matter. They all use the same type of a ping function. And what this ping test does is it takes a block of data and you can define it. You can even define how many times you want it to send, but it will actually send to the device, and that device will turn around and send it back to the source. So you're actually seeing communication going both directions, and it will tell you how long it took, and also how many times, if it did lose a particular packet, how many times it retried, or how many times it tried to resend the data. So that's a very powerful testing methodology, and you're going to find that, quite honestly, we use this a lot in our Ethernet-based systems because that is really what the information we need to know. Is the radio processing, or is it sending this, TCP/IP or the data information over the top of it? Because the difficult part is because the radios themselves actually just replace the 2 lowest layers in that Ethernet stack. We're replacing the physical and the MAC layer. So it doesn't really matter what protocol runs on the top of our radio. So this ping function allows us to jump inside of that protocol and see whether or not that data is going across there. Now, the tool that we have to kind of verify this is that we actually can try to also open up the radio inside of a web browser. You need to have the IP address and be able to talk to be able to function. So the tool that we've put together, though, is to verify if not the radio and the computer are actually set to the same IP subnet. And that tool is called the Discover utility. Now, as you're going to find that a lot of these tools that we're going to introduce you to are actually used in multiple steps within our troubleshooting environment. So the first one we're going to concentrate on is this Discover utility. Well, this Discover utility is a very unique tool. It's really what its primary purpose is to allow you to adjust the configuration of the radio's IP address and subnet so that it matches to the device it's connected to. There are also many things that it allows you to do. It allows you to update the firmware in the radio. It allows you to automatically jump to the configuration utility for the narrowband equipment, or even it'll automatically enter the IP address into a web browser, whatever your default web browser is, to do the primary configuration. Now, what this Discover utility does need, as far as a few troubleshooting things, if you aren't actually able to talk to it, is the radio, your computer itself needs to have a fixed IP address. In other words, if you're running on a DHCP network, which is perfectly fine, you just need to make sure that your computer is already logged into that. The easiest way to do it is just give your computer a fixed IP address. It's also really designed to display what radios are physically connected to it. Using it as a troubleshooting tool, and we'll use it here in a future slides here, but you can actually use it to see what's happening on, say, the remote side of the network also, if the radios are bridged together. But its primary purpose is finding out whether we're able to locally connect to the radio. So it's a perfect troubleshooting tool to find out, do I have Ethernet communication? If you plug this in, you bring up the Discover utility, hit Discover, If that radio shows up, the one you're physically connected to, we know we've passed the first test and can continue with the troubleshooting. So the next thing is that how do we verify the configuration? Well, things happen. You know, people are going out and troubleshooting these larger networks, and quite honestly, configurations can get changed. They can inadvertently get loaded into the wrong radio. They can get backed up. You may have somebody go out there trying to troubleshoot the network that doesn't really know what you are doing. But what we've got is that we have the ability within this to validate the communication. In other words, has the radio programming been changed from when the system was commissioned and it was working? So where is this configuration actually saved? Well, the configuration for each of the radios can actually be saved in 3 different spots. We can save the configuration through the web browser to a local computer. It's just a simple single file, and you can name that file by location if you want. When it goes to restore that file, it does not care what the file name is, just as long as the structure of that file has not changed. So the naming conventions of it do not really matter. There is also another unique feature inside of especially the Horizon series radios, that there is a backup memory card within there. So you can actually back up that information to a particular radio, and it'll be stored as basically a secondary image on that radio card that you can read out of. So if you're doing some kind of diagnostic troubleshooting and want to find out what's going to happen, or we don't want to lose what was originally programmed to it, you can actually write the program into the memory card. If the troubleshooting doesn't work out the way it is, you can read it back out of the memory card and you're done. This also gives you the ability to take that memory card out of one radio and then put it into a second radio, restore that image into that second radio as a clone, and now that radio can work. It kind of works like a SIM card in a cell phone. Okay? So these are all local changes that can be done to a radio. Another place that the configuration for a radio can be stored is inside of one of the software tools that we've got, which is called the ESTeem Networking Suite. Now, the ESTeem Networking Suite is a little bit different for the fact that it saves the configuration for all radios in one single file. So if you've got 10 radios, you're not going to have 10 separate files. You're going to have one configuration file that is going to work for all of them. So what are the tools that we got available? Of course, you've got the web browser inside of every one of the Horizon radios. It will give you verification. You can go through the individual steps to look at how the radio is programmed. You can actually use that to restore it in the Restore tab on there. The Discover utility, of course, can be used to not only bring up the radio, but there is a function within the Discover utility that will get the configuration from the radio and save or put the configuration to a different radio. And the thing that we want to really look at as far as this step goes is the tool called the ESTeem Networking Suite. Now this is a very, very powerful tool, and we're going to just kind of scratch the surface on what this software can actually do for us. But the biggest thing is that it is a visual programming tool. It allows you to set radios into the network, and then to make a connection between them, you do not need to go through the entire process of making them a peer link, setting them up as a bridge. You can very simply just draw a line between the radios, and it will then set up the configuration files for each of those radios to tell it, oh, I need to actually create a link between those. You can double click on that link to change the security mechanisms to it, the routing. There's many different features we can have within here. But what we're concentrating really on is how to use this as a backup file. The best part is that if you go inside of this ENS software and you save the file, you're actually, as we see here, there are 3 of them listed here on this particular slide. What it will do is it will actually save the configuration for all 3 radios. So if you need to actually change or verify that the radio you're troubleshooting is working correctly, you can actually download that off of these ENS and put it inside of that particular radio. Now, this ENS software has also some nice features to it, and we'll look at some of them here in the future, which is the monitoring section. But it allows you to actually do programming for both online and offline. So if we're going to be adding in a new remote to this system, you can actually put in what we call a dummy radio. It essentially acts as a placeholder, put it into the network, define all the routes to it, and then when the radio actually arrives, you actually just change it to the serial number you want to put in, or you put in the serial number of the radio you want to add, draw it to where you want to be into the network. it'll actually tell you which radios actually need to be reprogrammed, and then updates the configuration for all those radios and networks. It's an incredibly powerful tool. Outside of updating the firmware, because you can do it both network-wide, but there are changes within here which we call global-wide changes. In other words, those that are common between all the radios in one single network, such as the SSID, or the service set identification, or the network name, or things like the frequency. Of course, if a frequency changes, all radios in that same network need to be changed. So it's a very, very powerful tool, and we'll see what a couple other features for it here in just a second. Once we've established that the radio, we're able to talk to it, that the programming hasn't been changed, or it's programmed still the way it should be, the next thing we need to take a look at is how well this local radio is sending its data into the air. So really what we need to look at is three different things, okay? What are we actually testing here? We're actually testing the output power of the radio. We're testing the proper operation of the coax cable, if there are any, and quite honestly, the operation of the antenna itself. Now, there is a particular piece of test equipment that allows us to test longer runs of coax, or even short runs of coax. That cable is what we're testing here, is the SWR, the standing wave ratio. Okay, that really there's a lot more detail into what actually happens there, and we do have plenty of technical bulletins on how that's actually done. We'll happily walk you through it, but really the type of two tests that we can do is either we've got a directly mounted antenna, one that's like screwed to the top of the radio, and quite honestly, since there's no cable there, most of that testing is actually done by physically inspecting the antenna. Are there any cracks? Is there any, is there water inside of it? Is there any damage to it? Is there any corrosion on the connectors? You can look inside of there and make sure that the gasketing is still intact. And quite honestly, if it is a concern, you can just replace it with another radio. And if the problem goes away, hey, it was in the antenna. Okay, you can actually go to put this on the end of the meter, but to be honest with you, most of the testing that we would do is on longer runs of coax. Okay, we're running any kind of an external antenna. And for that, you actually need what's called a directional watt meter. Now, there are many different devices that you can get, very, very high-end pieces of test equipment into the radio side. But for most of our field testing, we found it very cost-effective and, quite honestly, very powerful tool just to use a standard directional watt meter with replaceable slugs. And the one that we use quite often is called a Bird Model 43. And it's been around for probably 60, 70 years now. And the nice part is for a field piece of equipment, there's really no instrumentation to it, as there's no mechanical hardware. So what you're really testing with is an actual analog meter. Okay? And I'll show you what one looks like here in this next slide. But what we're trying to do is we're trying to make the radio generate a radio signal, and then finding out how efficiently that radio signal is getting into the air. That's the purpose behind all of this testing. And really what we're doing is that you can actually go and turn on the radio inside of the advanced configuration. Under WLAN 0, there's actually a command there called radio on, and you can engage the transmitter. Because what we're looking for, this directional watt meter, this is actually a picture here on the screen here of a Bird Model 43. They make digital versions of it. There's many different types. This one happens to be made by Bird. There are different manufacturers of it, of course. But ultimately what it's doing is it's telling us how much power is going to the antenna and how much power is coming back from the antenna. Because no matching, in other words, there is no radio and coax that is perfectly matched to where all the energy that radio produces gets put into the air. It's because we just can't physically make anything that efficient. So there will be a certain amount of reflected energy. What we're trying to do is we're trying to minimize that, because that reflected energy, think of it this way, what you do is you have energy going out of the antenna and energy coming back at the same time. Those two can cancel each other out. That cancellation is that reflected signal, or that standing wave, and that reduces the output power to it. So the maximum we want to be able to see is about 10%. If you have a greater than 10% of your output power being measured by this directional watt meter being reflected back, there's a problem someplace in the coax or the antenna. Now, it doesn't tell you exactly where the problem is, but you can still use this directional watt meter to kind of find it. In other words, if you're measuring into the coax cable and you have a high reflected power, if we move that meter between the coax cable and the antenna, and we still have a high reflected power, the problem's in the antenna. If it's actually a low power, in other words, we're not getting enough energy to the meter through the cable, the problem's in the cable. Okay? So you can actually use this for a very, very high, high level type of troubleshooting. Where that's again found is because the radio, it's transmitting, it's turning on and off within milliseconds. So trying to measure that on an analog meter as the radio is running is just not functional. So we've actually added that into the advanced menu onto the Horizon radio series, this section that allows you to do or turn on the transmitter for an extended period of time. If everything looks good, the output power looks good, the antenna and coax cable looks good, well, it's not necessarily that the problem is at this local radio. It may be the site that's trying to talk to it, or something has gotten in the way. Now, whether it be a tree has grown or they've built buildings in between this radio path. So we need to then look at the next step, which is measuring the received signal strength. Now, this is a key element because this signal strength really points at a lot of things. What we need to do is we need to find out how much signal is being received at this local radio from who it's trying to talk to. It also will tell us at the same time how much interference there is in that area. In other words, are there other stations out there that we didn't pick up before? Because this is such a key element to troubleshooting or how the operation actually works, there are multiple ways of getting to how to measure this received signal strength. So we'll just run through a couple of them real quick. The first one, of course, you can always use an external spectrum analyzer. You can actually just plug a spectrum analyzer into the antenna, measure the incoming signal to it from that site, and it will tell you then how much signal strength is being received. Most people don't have that level of test equipment available to them. So we've put a lot of these same functionalities inside of the radio. The first one is simply inside of the web browser. If you go to the wireless status page, it will tell you how much signal strength is being received from a remote location. If it's got multiple antennas and multiple in, multiple out, it'll tell you how much signal is coming into each one of the two antennas. So this information is there and available. Because it is such a critical piece, we also can read this from the Modbus TCP IP registers inside of the radio. We have within the Discovery utility a special little application that will pop up. It's called the WDS Link Monitor. It will actually show you those stations that are configured as peers. It will show you their signal strength. And what's nice about that is it automatically updates on about a 1 second interval. So if you're aligning directional antennas, it's a quick way to put it in there and actually visualize where it's at. Another thing that has been added into it, and I'd mentioned to you when we come back to this, inside of the ESTeem networking suite, the last version that we put out here actually goes out and does a Modbus monitoring through those Modbus registers that I mentioned to you before, and will actually display on the screen what the active signal strength is to each one of those connections. So you'll just need the latest version of the ENS, which you can pull off of our website, and a updated firmware, which you can also pull off of our website. So the tools that we have available to us get us back to the web browser to be able to look inside what this received signal strength is. You can actually find it through the Discovery utility and discover it through the ENS. Essentially, every one of the tools that we have covered so far this morning will show you what the received signal strength is. That's how critical of a point it is. If you go into the actual web page and you're looking at the actual wireless status page, what it will do is it will show you the remote locations, both those that are associated with the radio. If it's got multiple SSIDs, which end they're associating to, these are going to generally be mobile clients. Peers, it will show you their signal strength at each one of the peers, what their data rates are. It also will show you the last receive. In other words, it will show you how often it's received a pull from that remote station. So if you haven't heard from it in 2 minutes, what you'll see is, well, I haven't seen that for 120 seconds. And so it will give you a good idea of how often I've heard from that and what was the last signal from it. The ENS is a little bit easier to read from that. What it does is it actually just simply displays it on the screen. The beautiful part of this is that putting this monitoring function on the ESTeem network suite, what it allows you to do is it allows you to display this on the exact same screen that you did the configurations on. But now it'll show you the RSSI, or the received signal strength information, the data rate, which is an average between the two, and whether or not, say as we see here on the screen, we actually have a mesh network, which path it's forwarding and which path it's blocking. So there's some key information to it. But ultimately what it's going to tell us is, do we have enough signal to operate, or has it changed dramatically from when the system was commissioned? Okay. If all of that still looks good, then we take a look at step 5, which we just put data across the network. Okay. There are many different ways of doing it. The fastest and simplest way, of course, we've already covered, which is running the TCP/IP ping test. Okay. You can do this through looking at the data rates, the testing methods. We can look inside of the web browser. As I mentioned to you, we can look inside of the ENC monitoring. It will show you the actual data rates and the signal strength going across there. So we know that the data is actually passing and that's being updated. But a quick and easy way, of course, is that ping utility. This troubleshooting tools is going to cover them all again, because really each one of them passes data across the network. But what you're able to do is, if you're able to go into the network and ping, in other words, send a TCP/IP ping to the remote radio or even the device beyond the radio and get a reliable response, the problem that you're trying to troubleshoot is not inside of the radio network itself. So let's go ahead and take a look at these troubleshooting steps again. We kind of covered them a little bit in detail, but if we go through there and we've validated that we can talk to the radio, okay, we know that that's not an issue. We've validated that we can run the configuration on it. That looks good. We've checked the forward reflected power on the antenna. If it's a direct line antenna, we've physically inspected it. We've replaced it. There's been no change there. We've looked at the received signal strength. There's been no major changes in the received signal strength from when the system was commissioned. And I can ping through various different network devices, ping the remote radio, ping the remote response. If all of these look good, then the problem is outside of the radio and we can move on with our troubleshooting. Another thing to look at here is you look at these and it's like, well, this seems like a very strict order that we're going into. Well, to be honest with you, they build one upon the other. In other words, to be able to read the configuration out of the radio, we need to have direct Ethernet communication to it. To be able to measure the received signal strength, you need to be able to know the configuration and the Ethernet communication. You could start here at the very last one and do a simple ping test. Okay? If it works, great, you're done. You can move on to continuing the troubleshooting. If it doesn't work, though, you're going to be going back through these 5 steps. So it's a very good thing to get into a practice on, because these are the exact same 5 troubleshooting, or basically testing methodology, that we use when we do the radio site survey and we go back and do the radio commissioning. They're used over and over and over again. So I would recommend that everybody get familiar, very comfortable with how these actually function. I want to thank you for your time today. My name again has been Eric Marsky. You can, of course, reach me at my email address, marsky@ESTeem.com. You can call into the main number at 509-735-9092. And of course, you can pull all this information, all of these utilities, and even this presentation, quite honestly, is going to be posted onto our website. So looking here, it doesn't look like we have any questions that have brought up here. So I appreciate your time and have a great day.